decreasing very well at this point, and I don't think I can go past 64. So I have some data here from an experiment, and this experiment involves swinging a pendulum back and forth. As the pendulum swung back and forth, its swings were smaller and smaller with each successive swing. So the data here is given for the initial swing and every fifth swing after that. So we're interested in what the relationship is between the swing and the swing distance. So I'm going to graph it and just see what I get. My y-axis, I'm going to let it go up to 30, and my x-axis, I'm also going to make that go up to 30 as well. Zoom out some more. I can see that the pendulum swing is going down, as we can tell from the graph, and it looks like it's forming some kind of a curve. So let's take a closer look at the data in the table. So from 26.5 to 19.9, we want to compare those two values. So what I'm going to do is I'm going to take B5 and I'm going to divide it by B3. And I've done that for all the other pairs of, in this case, y values. So I took this number divided by this to get this number. To get this value, I took this number and divided it by this. To get this value, I took this number divided by this, and so on. And if you look at these values, they're not equal, but they are close enough for us to say that this is an exponential relationship. So looking at the paper folding investigation, if I calculate the common ratio between pairs of y values in this case, so a 1 went from a 2 went to a 4 went to an 8, it's always going up by a factor of 2. So this is different than a first difference or a second difference. It's a common ratio. So I've divided 2 by 1 to get this, 4 by 2 to get this, 8 divided by 4 to get 2, 16 divided by 8 to get 2, 32 divided by 16 to get 2. We call that a common ratio. And we call this relationship an exponential relationship because of this. In this exponential relationship, we have growth, and so we call this exponential growth. In this exponential relationship, we have a decay or decrease in our y value, and so we call this exponential decay.